We're asked to use cylindrical shells around the x-axis, so we want to integrate with respect to y according to our text, and f of y is just the function in terms of y that bounds the two-dimensional region that's being rotated. Let's graph each of these. So this one here, if y is -1, then x is going to be -1. So there's a dot on our first graph. If y is +1, x is +1. And you should see, if you were to graph it in a graphing calculator to get more points, the graph should look roughly like this. That's the graph of x equals y to the third. Y equals 1 over x, that's a pretty classic graph. It looks something like this, except it crosses at 1, comma 1. And then it also goes this way, but I have a feeling they're not going to make us consider both regions. So there's y equals 1 over x. And then we have x equals 1 is this graph, vertical line right here, and y equals 2 is this graph up here. The region bound by all those graphs. Man, this is confusing because it could be this region. I gotta think about this for a second. There isn't one region where all four of those lines are a barrier, like a 1, 2, 3, because they all cross at 1, 1, except for y equals 2. Man, I don't know. I mean, I know it's not down here. Let's just forget about that because they gave us x equals 1 and y equals 2. Y equals 2 is up here. X equals 1 is over here. And this graph definitely goes like this. So it's like the x equals 1 part doesn't even matter. I'm pretty sure they want this region revolved around the x-axis. Oh, that's complicated. I don't know for sure, though. Okay, let me try this and we'll see if we get the right answer. Because look, there's 4 different curves. I should say curves because some of them are curves. But there's 4 different lines going on. There's no region that uses all 4 lines as a boundary. So I'm making a guess that it's this region here. Okay, so to integrate that, we need it in terms of y. We've already got it here. This is y. This is actually going to multiply x to both sides. This is the same thing as x equals 1 over y. So that would be this border. So I think we got to do 2 separate integrals. That's the integral from 0 to 1, and this is the bound. That would be this function here, x equals y to the third. So it's 2 pi y times y to the third, so it's y to the fourth. And then we need to do it from 1 to 2 using this, because this is now what's dictating the bound of the region with respect to y. So we said that's integral from 0 to 1, that's 2 pi y times 1 over y dy. And then those are pretty quick. This is 2 pi over 5, I think, because that's y to the fifth, so that's 1 over fifth. Yeah, and then this is, that's 1, so that's y, so that's 2 pi over here. So if we do that, that's 10 pi over 5, so this is 12 pi over 5. So I got A was 12. Let me just check that. I tried this region, but that also didn't give me the right answer in the answer key. Maybe this region. The problem is that these 4 curves don't bound one region together. They intersect, 3 of them intersect here, and we're only using 3 out of the 4 curves. So I think there's some ambiguity about which region they're asking us to integrate. So if this happens on the final exam, I've looked in the past, and there is one question that it does do this where it's ambiguous on which region they're talking about, and I give credit back. But that's one question, and the exam has many different questions in the answer bank, so you might get one that's not ambiguous. Like if they said they cut out x equals 1, then it's clear which region they're talking about because there's 3 curves and they all intersect for this region, and that would be the region I just did.